Hello SQL problem solvers, welcome back to our channel where we dive into the world of databases and bring clarity to complex data problems. Today we are going to explore the power of SQL in insurance policy data. So here in interview assignment, given that table structure, that is ID, a data type is INT, and we define this as a primary key. Policy ID, data type is unique identifier. Premium, data type is money. PremDate, data type is date. So here we have 7 queries on policy data table. So let's move on SQL Management Studio. Let's start it by setting the stage with our policy data table. Here I create a table and populate it with some sample data, and we can analyze and represent real world policy transaction. Now the analysis begin. In our first query, as we search the second highest premium, this helps us to understand the competitive landscape of premium rates. So first first I will show you our policy data table. Yes, I will show you the first query result, then we will explain. So this query uses a common table expression named premium ranks to assign a rank to each premium amount with 1 being the highest. The dense rank function is used here because it does not skip ranks if there are ties. After ranking the premium in descending order, the main query selected the policy ID and premium where the rank is to which corresponding the second highest premium. Next up, we keeping our finger on the process by retrieving the 5 most recent premium dates from each policy. It's crucial to stay updated on latest policy activities. So let's first see the output. Here is the output. So in that, this query retrieving the 5 most recent premium date entries for each policy ID. The row number function assign a unique sequential integer to rows within the partition of the policy ID ordered by PremDate in descending order. The outer query then select the top 5 most recent date for each policies. Query, that is a frequency of payment, can tell us a lot about customer behavior. So we use the lag function to compare premium date and calculate the difference in days between payment. So here is the output. It's showing null because I enter all unique policy ID. So if there is more than 2 record of same policy ID, it show data here, but in my table I didn't have, so it's showing null. Let's see what we did in that query. So here we calculate the difference in days between current prem date and previous prem date for each policy ID using the lag function. The lag function allows us to access data from previous row in same result set. Date different function then calculate the number of days between this date in same result set. Date different function then calculate the number of days between this date. Now moving on fourth query. Here we understanding the distribution of policy is key for market analysis. Our fourth query just that giving us clear picture of policy spread across our data set. So we first run this query. So here all policy count shows 1 because we have all unique policy IDs. This query returns the distribution of policy ID values by counting the occurrence of each policy ID. We group the result by policy ID and use count to get the number of record for each policy. Let's move on fifth query. First we will see the output. So here we have duplicate count is 0. If there is any duplicate, so it's show here. So in this query, in fifth query, this query identifies the duplicate policy ID entries in the table. It groups the data by policy ID and use the having clause to filter group that have count greater than 1 indicates duplicates. Now moving our sixth query. So here is the output. Diversity in payment date is just as important. With our sixth query, we count that unique premium dates, shedding light on payment diversity. This sample query counts the unique prem date value in the table using distinct keyword, which ensure that only unique dates are counted. Now it's our last query. So here is the output. We bring it all home with query that sums up the total premium collected each day. This gives us valuable insight into daily revenue trend. The final query calculates the total premium collected for each day. It casts the prem date to data type to remove the time part and then group the result by this date. The sum function adds up all the premium from each group, giving us the total premium per day. So this is a series of SQL queries that can transform raw data into actionable insights. And there you have it. We will created a table, inserted a record, and executed various SQL queries to analyze the data. If you found this video helpful, please give it a thumbs up, share it with your friends, and subscribe our channel for more tech tutorial. If you have any question or suggestion, leave comment below. Thanks for watching, and I will see you in next video. Until next time, keep coding.